short video, I'll answer a question asked by Uzair Yamin. Right, he wants me to answer this question. He wants to know what is CG in case of a NOT. Right, it's a very good question. For a NOT, we know we have a PMOS transistor and an NMOS transistor such that they are connected like their the source terminals of both are connected to the power supply. The source of PMOS is connected to VDD. The source of NMOS is connected to ground. The drains are connected together and they form the output, whereas the gate terminals are connected together and they form the input. Right. The CG is the input capacitance of this NOT. So the input is connected to a PMOS and NMOS. So there must be a capacitance from the gate of PMOS to ground, and there must be a capacitance from the gate of NMOS to ground. Right. This we call as CGP and this CGN. If it is a symmetric inverter, this PMOS is R times larger than NMOS in order to have equal rise and fall time delays. This C oxide is the capacitance of silicon dioxide layer. The formula of C oxide is given in chapter 3. I don't remember the formula right now, but it is given in chapter number 3. You can go and check. Right, as far as a VLSI designer is concerned, C oxide is not in his or her control. He or she can control only the aspect ratio, the width and the length. So the width W, this P is in subscript. This WP is written like this, W subscript P. This means the width of PMOS. Similarly, WN is written like this W subscript N, width of NMOS. And this R is mobility ratio. WP has to be R times WN if we want to make a symmetric inverter. For symmetric inverters, the width of P is R times the width of N, and then we can have a middle voltage that is equal to VDD by 2 and equal rise and fall time delays. So since WP is RWN, we can put it here, and this remains the same as such as it is here. And then we can take WN times L common, and this is C oxide WNL, and there should also be a term that is missing. We have taken C oxide, WN and L common, so the thing that is left behind is R plus 1, which Uzair forgot to write here, R plus 1. So R plus 1 times this is the capacitance, the minimum capacitance. Because why we call it minimum? Because it is the least capacitance out of these two, because WN is smaller than WP. Therefore, the input capacitance of NMOS, this CGN, would be smaller compared to CGP. Therefore, we call it minimum because it is the minimum of the two. So this is R plus 1 times. So CG is R plus 1 times. This is R plus 1 times, and this whole that I have underlined can be written as C minimum. So C of the NOT gate can be written as R plus 1 times the minimum capacitance, that is the CGN, the capacitance of the gate. I hope I have explained it to Uzair's satisfaction.